So in these problems, we're asked to simplify the trigonometric expression. And so some skills that we can use are the substitution. We can sub in something from one of the wonderful world of identities. We could factor. That's a very helpful thing too. We could also use some other difference of two squares, etc. So there's a lot going on. But here, what do you notice in both terms? A sine of x. So what factors out? Sine of x. Now, what stays in? A cosine squared of x minus 1. Now, is this your identity?
Yeah, it's squared. No.
So now here, if I were to commute this, then I would need to factor out a negative there. So now I put a negative out front, and this here commutes to cosine 1 minus cosine squared of x. Now I can substitute here using my identity, and this becomes sine squared. So the red sine x stays the same, and this one becomes sine squared of x. Now all we do is add our exponents. I bring down the negative, I bring down the sine, I bring down the cube now. Boom. So this one doesn't have any factors that we know of immediately, but I can rewrite secant to a cosine reciprocal and cosecant to a sine reciprocal. So let's simply put it like so. The secant becomes 1 over cosine of theta. All over 1 over sine of theta. So we have a complex fraction. But of course, we can rewrite this and take the reciprocal of my denominator. We don't even need to write the over 1. Now when we combine these, sine of theta is your numerator, cosine of theta is your denominator, and that by definition is my tangent function. Hashtag, that was very satisfying. Now, when we take a gander at this, I see nothing yet can factor out because none of these, there's no term here that's also over here as a factor. So I can substitute in. So this here can be rewritten as 1 over the sine of x minus cosine x does not need to be written, and cotangent can be rewritten as cosine of x over sine of x. Yay. Now, what can be factored out? Not sine, but 1 over sine. So let's pull out 1 over sine of x from both terms. Notice if you divide this by itself, you get 1. So the red here becomes 1. And over here, we end up with the sine x comes out, and what's left in the numerator? Or cosine squared.
Why is that 1 there? Just because you took the 1 sine out?
The insanity.
So sine squared.
Okay, so what does this get substituted as?
Sine.
That is sine squared. So my ratio there stays the same, but over here becomes sine squared of x. Good. One of those go away, all of those go away, and what are we left with? Sine of x. Hashtag, again, very satisfying. So this one is actually way less confusing than the other ones because my denominator is already written in a Pythagorean form. So the numerator does not need to be changed, and we'll see why in a second, cosecant of beta, because the denominator, according to my lovely little Pythagorean identity, is cosecant of beta. So what's my answer?
Wait, isn't it squared though?
It's squared.
Oh, squared, thank you. So let me... Good, so I forgot my square here. Bink! So let's fix that. And now, all of this cosecant drops out to become a 1, and one of those drop out. So this now becomes 1 over the cosecant of beta. And that by definition is going to be my sine of beta. Because the instructions on here are factoring, we need to consider rules. Now remember, when we factor, one thing we can do, factoring, is going to be GCF. So is there a common factor to pull out? Other ways of factoring is if you have a difference of two squares, right? A squared minus b squared. You can factor that to be conjugates. That's only applies to quadratics, of course. And we also know other types of factoring, your best friend, snowflake, or other method. Okay, so notice here, what we need to do is consider this whole thing effectively to be a variable. So watch the magic here. You could either leave it as is, or just call this whole thing a squared minus 1. So what does that look like to you? Doesn't that look like a difference of
Perfect square.
perfect squares? So what would be my conjugates? A minus 1, a plus 1. But what's the value of a?
Cosine square.
Actually, it's just the cosine, sorry. So I just called, let me define it over here so that we see here. I defined a as the cosine of x. So now all I have to do is substitute back in. This one is the cosine of x minus 1, and this one's the cosine of x plus 1. Now you don't have to do the substitution thing. You could have jumped straight to the conjugates if you just considered the whole, all of this to be your variable squared. So you could skip that entirely. Some people find it helpful because you don't have to deal with so much what looks like convolution. This one, there's no GCF all around because this negative 12 doesn't have any sign. So what I can do, though, is let me go ahead and substitute and call a my sine of x, which means this becomes a squared, and this becomes negative 4a. A squared minus 4a minus 12. Now, does that look a little more simple? Yes. So if you, however you factor it, I don't give a rat's potato, but I like to use snowflake. So again, a times c, the coefficient here times the negative 12. So that's a negative 12 there. I also am just going to put a single a there and there. And my b, which is negative 4, goes on the bottom. Now I find my factors of negative 12 that add to negative 4. And the two factors are negative 6 and positive 2. So what are my factors here? A minus 6 and a plus 2. Now what's the value of a?
Sine of x.
It's sine of x. So now let's substitute back in. Sine of x minus 6 and sine of x plus 2. And we know we're done because it is a multiplication problem. It is something times something. So in problem 9, instantly we don't see anything that can factor out. These two are different, so it's not like I have a quadratic and a linear term. So what the Gehenna do I do? Well, we can use a Pythagorean to substitute in. So what is secant squared? You said 1 plus? So 1 plus tangent squared of x minus the tangent of x minus 3. Now combine your like terms. This is a 1, that's a negative 3. So my tan squared comes down. My negative tan of x comes down. And a negative 2 comes down. So if you were to call a the tan of x, then this is a squared, and this is minus a. So it looks like a squared minus a minus 2. Snowflake. So the coefficient here times a negative 2 is negative 2. My b goes on the bottom, negative 1. A's go there. And now I find negative 2 times positive 1 will give me negative 2, but negative 2 plus 1 gives me negative 1. So my two factors before I substitute is a minus 2 is one of them, and a minus 1 is the other.
Could it be a minus 1?
Plus 1.
Thank you, a plus 1.
Couldn't it be negative 1 and positive 2?
No, because those don't equal -1.
And now we substitute. A is the tangent of x, so tangent of x minus 2 times the tangent of x plus 1.
Yay.